Hello, everyone, and welcome to another Jakarta Tech Talk. My name is Serena, and joining us today is Baslur and Shaf, who will be presenting on the topic of Java plus LLMS, a hands on guide to building LLM apps in Java with Jakarta. If you have any questions today throughout their presentation, please put them in the chat or use the Ask a Questions tab. Without any further delay, Baslur, Shaf, over to you.
Cool. Thanks, Serena. Excited to be here and excited to talk about large language models, which all of us have been hearing a lot about since the last year or so. We want to talk about Java and how Java is one of the best suitable languages to work with large language models. Before I go on, Basler, maybe you want to introduce yourself and we can take it from there. Can't hear you, Basler.
I'm sorry. Hey, I'm Bozlu. So I'm a Java developer. I like to work with Java, and I love JakartaEE. I love LLMs, and I'm trying to learn as much as I can and integrate the Java with LLMs. So this is going to be an exciting presentation because we have prepared a lot of demo. Yeah, over to you, Chef.
Yeah, thanks. And yes, my name is Shaf. I'm a developer advocate, a technical editor. Yeah, I've worked a lot with Java for a long time, and it's exciting times using large language models. And as we went through this journey, me and Basler, we learned together. We put some code together, and we start to make sense of it, like most of us do. And I think we're very excited to share what we've been building and working with and spread the knowledge as well. So feel free to ask questions in the chat, and we will try to take them as we go along or at the end of the session as well. So let's get into the presentation. What we will cover today, just a quick introduction about large language models. Usually we could take just another session explaining large language models, but we want to cut that and get on to the demo. So we will do a quick introduction. We'll go into a demo with prompts and tools with which Basler is going to go through, and then I will step in after Basler and do some RAG and model context protocol, which we all hear a lot about these days. So hopefully it will be by the end of it, you would have known something about large language models, Java, and Jakarta together. Um, just to put the context correctly first, why should we have large language model integration? What benefits we might have? There's many answers to it, but I think one of the interesting answers is that large language models gives us the possibility to do natural language work with our systems in a natural language. Like you go on GPT today or any of the other Gemini, etc. There's so many of them. Or if you use LM Studio like me, you would just type in a question and you get an answer back, whether it's code, whether it's poetry, whether it's summarization, etc., etc. So there's lots of these use cases, and what you're able to do is work with them in natural language, and that's great. And that's how large language models work. Without going into too much depth of how exactly that works, hopefully we can dissect that in the demo as well. But if I take an example of systems today and APIs and databases or unstructured data or structured data, whatever that is, they have system boundaries, and they only have the context of that specific system, and that's great. And I mean that's how we have built systems, and they work really good for us. But once we want to enhance the user experience, have a more natural language way of doing it, or expose our functionality into large language model, there's a different way of doing it, and that gives us a big benefit because hey, now you can actually create systems which can express themselves in natural language. A good example could be, let's say, reports, right? Like you do reporting, you maybe log into your net bank, and you want to see, okay, what did I do in the last 1 year? Maybe you want to do that, and if or last month, and you look at a very rigid columnar sort of tabular data, that is great, and then you start to process on top of it. But what if you were just able to ask the system, hey, what were my top transactions in the last 3 months, and it's able to give you some of those data, right? So there's interesting use cases that can have integration. It's not always the same. It's not going to fit everything. It's not like we call a silver bullet for all solutions, but it gives some of these good experiences to us, including sentiments and processing, etc., etc. And lastly, the limited expertise in AI adoption is a big challenge, and that's what we want to address today as well. Is to give that knowledge out that we've been working on as well. So you can hopefully start with this journey using JakartaEE, etc. Um, to make it extremely simple, lots of words you will hear, and don't worry too much about all of these. When I looked at them, I was extremely scared, and that's exactly the reason we put the slide here, is because when we look at all these words saying top P, top K, sampling, hallucination, normalization, attenuation, etc., guardrail. So I can go on, right? And there's lots of words here, but don't think too much about it. There is a simpler way to do it, and we will show you the simplified way of getting onto this journey as well. What we use with JakartaEE today in our demos is we use LangChain for J. So LangChain for J is an extremely amazing and awesome tool for integrating with large language models. It gives us a lot of possibilities to create, connect with our APIs, connect with our data, send that into large language model, creates these awesome tools that large language models can invoke, maybe even create some agents, etc. Generate these workflows. And why not with Java? Because Java is one of the, biggest enterprise languages, and why can we not use that expertise and data that we have in the enterprise to actually make sense of large language models together? So it's a winning combination. And that's pretty much it from the presentation side. So I kept it under 7 minutes, and I hope Basler is going to entertain you more on the demo side. So Basler, over to you for the demo.
All right. Thank you, Chef, for your wonderful presentation and putting the context straight. So I'm going to go ahead quickly and share the demo with you all. So bear with me. And we have plenty of demos. So hopefully, I'll try to touch a few of them, because, demo is demo, and something can go always wrong. So bear with me, and and hopefully it will be a pleasant you know, demoing. All right. So what we did is essentially we have a Eclipse starter for Jakarta app over here, as you can see, where you can generate your Jakarta scaffolding. So basically, essentially, what it does is you can specify your JakartaEE runtime, version, Java SE version, all of those things, and then you can generate. You click on the generate buttons, and it will give you a project. And on that project, you can then start adding your own code. So that's essentially how I started, and then I gradually added more code to it. So that's essentially it is. And I can share with you the basic scaffolding. This is the first version of the demo. So that way we designed this demo is we added some sort of steps. It's a kind of a workshop format. So the idea is once we shared the demo, we can share the source code to you, and you can play around. You can go step by step. So first step is pretty basics, and then you can add a layer on top of it. So you go first one, step 0, and then step 1, and all the way step 8. And we have also step 9 that Shaf is going to show you the demo. So the first
Hey,
version,
Basler, sorry to interject. Could you zoom in a bit?
yes, that's what I'm essentially going to do in a bit. So all right. This is the first version. And if we run this, we are using Wildfly over here. So as you can see, I started the application. This is the first one. And it doesn't have a lot of code. It has a chat WebSocket, some configuration, and the interesting part is, which is this class that is LangChain services. So I'm going to explain this, but before doing that, let's show you a demo first. Um, um, so when we run it, we get this UI over here. So this UI has a button over here in the left, in the right bottom corner. So if we click over here, you see it's pops up the window. It's essentially a chat interface where we can talk to an AI through an API. So we can do that essentially with Gemini or ChatGPT, right? But over here, the idea is how we can use the API and integrate that to our own applications. So that's essentially what I'm trying to show you. So over here, if we say something, hey, hello, so it will immediately send me a response. Hey, it says, hey, hello, how can I assist you? So that's how we can keep on having conversation with the Jet API. So to achieve that, what we did over here is essentially we written a class called LangChain services. So, like Shaf said in his presentation, that we are using LangChain for J. So, LangChain for J is essentially a abstraction, a framework. You could say library. There is a distinction between framework and library. I'm not going into that, but essentially, what it does is it's abstract all the things that we need to do to achieve the communication between a LLM and our applications. So to achieve that, we have a POM over here, right? We need only two additional dependency, which is this. Although we're using the this version, which is 36, but it's frequently getting updated. I think it's beta 1.0 is available now. We need to update this version as well. But this is essentially the two dependency that we need, and it provides all sort of abstraction. First of all, it exposed a class that calls OpenAI chat model over here. So we created this open AI chat models, and then use the builder pattern over here. We specified all these required things that it needs. For example, it needs an API key, obviously, because we need to communicate. We're using over here chat OpenAI API, so you can go to your dashboard of OpenAI and create your own API key, and then you can fit over here, and this is something that we stored in a configuration. And then also you have to specify the model, right? We have a plenty of model out there, so you can specify the model, and then there are some other configurations that you may want to add. So these are optionals. The two things that required, which is API key and then model name, and that's all. And then you can essentially communicate with the chat model over here. So over here, as you can see, we have a method called chat model.generate. So if you send a message to it, and it will respond back to you. That's all it does. So on top of that, we use a WebSocket so that we can communicate with defense UI that I showed you earlier, right? So that's essentially it is. I'm not gonna go into the WebSocket how we did it. I mean, you can see the source code. Having a WebSocket in JakartaEE is fairly simple. You can just specify class, and then over here you can mention the service endpoint, and that's it. It's pretty straightforward. So I'm gonna skip it, and then we have some JavaScript magic on top of it, so you can see the source code. But that's essentially we need for the basic one. And we also added a few stuff over here so that you can configure your parameters. For example, we are using GPT-4 mini over here, but you can definitely use some other models. For example, if we go for GPT-4o, and then we can specify the temperature. Temperature essentially is how the model behavior. You can control all these parameters by using this interface. Not essentially we need to do it, but you can if you want to control the behavior of it. For example, if I ask it to generate a Java code over here, hey, can you generate a hello world Java code? It will generate a Java code over here. But if we change the temperature over here to, let's say I want to do 2, and let's see what it does. So it will increase the randomness. So let's go ahead and try it again, and let's see what it does.
Can
Hello.
you zoom in a bit, Puzzler? It's yeah.
Okay. Um, um, so 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 essentially what it's going to do is it's going to take the parameters, and as you can see over here in the log, it's doing all sort of works, and it will respond back something with the change of parameter that we did. So Um, it's taking longer than expected, but let's skip this for now. And one thing we have to, as you can see, it increased. Okay, so it's written something, but it's not something what we expected because we added a wide range of randomness. So that's how we control the behavior. And LLMs is somewhat unpredictable, but we can control it based on the parameter and all those things. So all right, that's the first one, and then we're going to quickly swift into other demo, but this is the first step. Then we have another step which is called prompt. That's how essentially we can control behavior more. We can control the behavior holistically. So let's go ahead and show that. So we have to start again, because uh, that's how we designed the applications, so that it's easier to follow. So it takes a bit of time, and let me see if it started. um, so the next step is essentially a prompt is essentially how you how so basically you ask a question and the LLM is going to respond, right? But you can specify how it's going to behave, and then you can send the message. So there's a two things we need to remember over here. Two annotation, especially it's specified by LangChain 4j, and there's things called system message and then user message. So system message is essentially is how you're gonna how the LLMs are gonna behave. So you specify, for example, over here we mentioned that this is a uh, sarcastic Java champions tone. We specify the tone. It's had to be witty, sarcastic, and humorous, and all those things. We specified that, and now if we ask a questions, it will try to mimic, try to do that the way we specified. So let's ask a questions quickly. Okay, so there's a little glitch over here, so I have to cache empty the cache, and hopefully it will work now. Okay, let's see. Okay, so hopefully this time it will work. So let's see, and we can specify the prompt over here, and over here we have also the system prompt looks like this basically, right? You are the Java champions with a sarcastic sense of humor. So if I ask a question, tell me about the single tone pattern, and as you can see, it will you know tell me something that is pretty sarcastic. So that's how it does. Okay, so probably it didn't get applied. It's probably the casual chat. Okay, let me try again. So okay, switch this to Java champion mode, and I'm gonna ask this same question again. Let's see what it returns. So as you can see, it says ah, single root parent, because who wouldn't want to make sure that class has only one instance. So basically the message is beta sarcastic, right? And then in the end it says I'm the real Java champion. So basically over here, I mentioned that in the user prompt, respond about the topic that we provided, and then always respond at the end with I'm a real Java champion. So this is how we can control the behavior of a prompt. So essentially what we did over here is differently from the other one, which is in this LangChain service, we created an AI service. Let me show you that. So over here, so this is our model. So we created a model over here, and then we set a personality over here based on the configuration. So we did a bit of configuration, but we add a personality over here. So so Swiss opportunity is what it does is basically it take a personality because we have plenty of them over here. We have chain of thoughts, Java champion, movie summary, so a few of them, and then it's create a personality based on the AI services. It's also an abstraction. It's somewhat similar to a Spring Data or Jakarta Data. So you specify your intent, and then it takes care of all the abstraction. So you can take a look and check all these others. So I'm going to simply move into the next demo because we have not a lot of time. So next one would be tools that I'm going to share you. But before that, we have another project over here called memory. So the idea is, if the API, the LLM is designed in a way that it doesn't have a memory. So its works is like, you set a questions and it responds. That's it. Fire and forget. But to have an effective communication, we need to have context of the previous conversation, right? So that's what essentially does with the memory. So we can specify memory, how much data we can retain the previous conversations. With this over here, we have specified that. As you can see over here, we have a abstraction called chat memory providers, and then we have a message window, chat memory, which is basically how we're gonna store them. We can store in database, or we can store in them in memory, and we can set up all those things, and then essentially at the end we use AI service and put all those things together. So that's essentially it is. So if we run this, what it will have, it will remember the previous conversation, and when you ask the next question, get all this previous context and send back to the LLMs, so that LLMs give you a proper reply. All right. So moving ahead, there is another interesting demo that I'm going to do, which is called tools. So the idea is, um, LLMs can do not a lot of. I mean, it can. It's an amazing thing. It can do a lot of things, but at the same time, it probably doesn't have the context of your own applications, right? For example, it doesn't have access to your own database, or local logic, business logic. What if LLM does need those things to give you a proper reply, proper response? Now, for example, let's say we're doing a banking transaction and you are asking for a specific transactions. So LLM doesn't have any context about those banking transactions. So what you can do is, you can specify a function calling behavior. You can specify a function. You can provide an intent to LLM that we have a function like this. If you need this information, you can call this function, and LLM can decide to call this function to get more context. So that's essentially what I'm going to do in the next demo over here. So we have specified a few tools. For example, this is a typical tools look like. You will have a simple class over here. It's a web-based tools, and then you have a message, and then we have annotation called tools. Before going more ahead with this, let me just run this so that it takes a while. So what it essentially does is, let's say, so we specified a function over here, get web-based content. So if I provide a URL, it will fetch this URL and then parse this and return the text to the LLM, and then LLM can decide what it needs to do with this information, right? So this is how we specify a function. Now, over here, if I go over here, if I ask the questions, hey, do you know what, for example, do you know what was my last article on my blog was Lucia. So now, if I mean, this is the information I provided, right? I asked these questions, but LM probably doesn't know about my personal blog and how to face that. Um, Now, since we have a tool over here, it will be able to do that. So let's see if it can return the informations. Probably I need to refresh it. Okay, so let me ask this question again, and let's see if it can respond these questions. Um, so let's see if it's doing that. Um, you know, demo is always uncertain. Sometimes something works, sometimes doesn't. So it looks like it's not working. But we will move ahead and explain how we use those tools in the LangChain for services. So essentially, it's the same thing like previous one, right? So we have specified the chat model, we have the AI service over here, and then we can specify all the tools over here. For example, we have a JakartaEE project generation tool, we have web page tool, we have Java compiler tools, we have specified three tools. Okay, I'm going to go ahead and share with you one. For example, this one is essentially mimic the whole process over here. We specify all these, Jakarta E core profile and all these specify all those things, and then end of the day it generate the project in a downloadable format. So essentially over here it does exactly everything how we specified. For example, we specify tools over here. It's called generated. We provide the information. Generate a JakartaEE project with customizable configuration. If any input is missing or unclear, request the input. So it will do that, and it requires all this information, and then it go ahead and do that. So that's essentially it is. So let's see if let me try refreshing the clearing the cache and try it again. Let's see if it works. Okay, so let's see if it works. Hey, can you generate a JakartaEE project for me? Let's see what it returns. So it says, sure, I can help you to generate JakartaEE projects. Let's start with JakartaEE version. So basically, it asks me whether I need to which version I'm gonna use. So it asks me JakartaEE 10. I'm gonna reply 10. So let's see. And then it asks me the following question, which is, next question, which platform, which JakartaEE profile do you want? So what I can do is I can ask, it will keep on asking all these questions until it has all the questions. So what I'm going to do is I'll say use all the default. So now it says, got it, I'll use a default setting for JakartaEE project, but it asked me to Jakarta standard edition. So let's go ahead 17, and let's see if it asks more questions or not. Okay, so it's still asking more questions. So let's see if I can specify that. Okay, I'm gonna say no over here. So basically it's asking me whether I need a Docker support or not. I say no. So it seems use default. So it asked me the last question. Lastly, please provide the artifact ID. I'm gonna say use default one. So it says it got all this information, and based on that it's going to produce the artifact, the structure that we need. So as you can see over here, it's doing all sort of things. It's a quite busy over here, right? As you can see, because it takes a while to generate entire project. But essentially what I'm trying to say is LLM is not supposed to know how to generate the JakartaEE project. That's the logic we wrote by ourselves. So that that's how tool helps with LLMs, and we can specify our tools. Tools is essentially a function that the LLM will try to execute if it feels it's necessary. So we have a specified three tools, right? But it knows exactly which one to call. So for this purpose, it call this generate function, because that's what it requires. But it didn't call other functions. So that's essentially it is. All right. So that's the kind of demo I had. I think we are about time to see the next one. So I'm going to hand over to the Shaf. Before I move in, good, I hand over to Shaf. If you have any questions, that's now is the time probably. And as you can see, I'll spend one more minute. As you can see that it generated the project, and if I click on over here, as you can see, it's in fact, it's a downloadable zip file where we have all this entire project exactly same way it does. So that's how we can use tools, leverage tools to inject our own own what do we say, um, own logic of own business logic to the process. So all right, thank you. There is a questions over here. Is frequency penalty same as top p value? Shaf, is it? I don't think it's the same. Frequency penalty is different. Shaf, do you want to answer that?
Well, I do not have the details about frequency penalty, but yeah, um, top P obviously is different, like you had in your parameters there as well.
All right. I stopped sharing my screen, and the floor is yours.
Yeah, I was looking at your tools and I was thinking like, okay, this is great, like, it looks awesome and everything, but I could have done the same thing generating a rule, right? If and else statement and ask the questions. How do you see it as different being from that? Because that's the standard practice we've been used to.
So the main difference between this is it's so what I mean. Our traditional system is more of a rigid system, right? We define the rules and only works if we specify how it is if we request how it is specified, right? It's more rigid. It doesn't understand sentiment. It doesn't understand it probably doesn't have the whole context. But so if we use tools in a way with the large language model, it become more fluid, I would say. It understand the conversation, because that's how we speak to other people, right? When we speak to other person, we doesn't always specify all the nitty gritty. This is how you are going to do. We just speak naturally. So if we use tools and then LLMs, you know our application, if we first those, if we put all together, it's become more fluid, it become more natural. So this is the way it react, that this is how we specify. I mean, if you want to build this entire uh, download JakartaEE project, or JakartaEE project, how you're going to speak to another person, right? So exactly, this become natural. The tools now can understand nuances, understand you better. So it gives us more user experience, I would say.
So could I have just said on the prompt, generate a new project, Jakarta project for me with all the defaults, rather than it asking me all the questions?
Yes, we could do that. I mean, we can do that. I can show you that because we specified all the defaults. We can start with that. Hey, take everything what I have default over here, um, uh, and it will not probably ask me any more questions because it knows all these defaults. But since I didn't do that, it needs to know
Yeah,
all this information, and that's why it asked whatever necessary.
that exactly. So it kind of detects what's missing and then it can ask you if
Right,
it's not.
right, exactly.
So thanks for the demo, Basler. Just interjecting some thoughts there. But what we've seen so far, obviously, you have the system prompt, where we have the personalities. You can also have user prompts, all connected together with the AI service and tools. Like Basler showed, you have multiple tools that you can do. We have some more tools demo, but I think we didn't go into that. And then, as always with the large language models, it's so much of exciting stuff going on that we keep on, we have new demos coming up. So our steps are also increasing as we are adding this more. So feel free to jump onto the repo and take a look at that. We are using Wildfly at the moment for the underlying container. And we use Jakarta E10 at this time, right? So moving on to the other part of the demo, retrieval augmented generation, RAG, you might have heard a lot of times, and there's many ways to explain RAG. And I think for me, from a developer perspective, the most simplest way is, it feeds the relevant pieces of information from your knowledge base to a large language model with the user queries, right? So yes, this is extremely simplified explanation of RAG, but typically that's what you want to do. You have a system that basically is let's say the large language models. Large language models don't have a memory. They specifically just speak in natural language, and that's great. And they were trained on certain data set, like I believe GPT 3.5 was trained on Common Crawl data set, which was about 500 gigabytes. It's publicly open data set. But what about data sets that are local, which I have in my organization, or which the large language model doesn't have, right? So that's where we use RAG. We will take our own information, put it into the large language model, and then try to make sense of it. But as we do it, there are a couple of elements that we need to touch upon. One of them is the vector store. So we will store information in terms of vectors. And the reason we do that is because we create a numeric representation of the text. And when we create this numeric representation, we basically can do a similarity search when a user queries certain things. And obviously, there's an algorithm to do those vectors, and that would match in that sense as well. So typically, not exactly the same, but you could say, hey, I have a hash code method that I wrote, and every time it returns the same code. And that's how I check stuff. So sort of in a way, vector search also works the same way, is that based on the user query, it goes and finds the similarity patterns within that. And in the demo that I'll show you, we'll take some documents and do that. So let me move my screen onto the demo. And I think, let me just do it like this, that I will enter presentation mode. So here we have another, simple demo where we are basically just using LangChain4j, a JakartaEE project. So if I go here, just show you my step, which is called EasyRag. In EasyRag, I have a file which is pretty much a document, a very, very important document, which talks about Java developers. And obviously, this kind of document you will not find in large language model. At least you won't find it until the March of 2025. Maybe something is trained after that. They probably picked it up from GitHub as well, right? But this is just a standard document that I actually generated from a large language model itself, but it's randomized. It talks about Java developers. There are multiple personalities of Java developers. And what I want to do is I want to be able to ask the large language model about these personalities. So that's my typical use case, right? So that's what I'm trying to do in this scenario. But as I do it, obviously, what I want to do is that I want to be able to configure this in a same way. And as we saw in the previous section, where we have a prompt. So what I want to do is I want to tell the large language model, before I even do anything, that, hey, you are a personality expert. I will ask you about a person, and you will tell who they are in less than one sentence. If you do not recognize the name, you will say, I do not know this, or who this is, and try again, right? Now, obviously, this is an interesting prompt. It's just a prompt. It will behave differently on different large language models. I know large language models that do not respect the one sentence limit, right? Or do not understand it. So purely, again, prompts are subject to the actual large language model that you use, and you should always be aware of it. So if you ever thought, hey, I wrote something with Llama, and now I use something different, which is maybe Gemini or Quen or whatever model, and I don't get the same sort of response. And that the reason is because they all have different base models and they all behave differently, right? So that's something. Or you cannot migrate from one large language model to another and say that expect that the same results will be the same. So anyway, so in any case, this is the prompt that I wanted to use. This is what I'm using, and it should understand it, right? Then we also have some basic configurations, same as what Basler showed, but we just picked them up from the microprofile subsystem. And then finally, we have a startup bean, and that's where all the logic is. Everything else that Basler showed you, it's sort of the similar UI. Everything is same, but we have added some more components, and these components include, for example, I use a PG vector store. I use an embedding model, and an embedding model, what it does is that it's going to take my text and convert it into this numeric generated values that the large language model can actually understand. And I'll just show you in a second how I do that and how that works. I'm using Postgres, so simple. Obviously, you'll see some select statements here. Then what I do is I want to load my document. So I have a file system document here. What I'll do is that I'm just going to open up my terminal, and that should open with 12 here. Hang on, I always forget. Yeah, going in presentation mode is never easy. Let me just put on the terminal from here. Terminal F12, yes. Um, anyway, so what I want to do in this demo is first I want to set up my large language documents directory, which I want to tell it that, okay, it's residing in the documents, and it's the same document that I showed you earlier, is the markdown document. You can store PDF documents, you can store any of them. With LangChain4j, there are multiple document processors. You can have Apache Ticker document processor, you can have a simplified text document processor, and there could be others as well, right? So it's pretty simple. It's just going to go in this directory. It's going to load all the documents. And if you were using an S3 storage, like if you were using Amazon S3, or if you wanted to use MinIO, you can also use those for loading up your documents in from those systems as well, right? So it's quite simple, nice and easy. The other thing that I do is, and I think what I should do in the meantime is that I'm just going to start up my server. So as it starts, I can explain that. What I'm doing then is that I use ingester. I use the embedding store ingester, and the embedding store ingester is basically just using a basic in-memory embedding store that we have, and basically uses the default default that comes with it, right? And then finally, we store those embeddings in the PG vector store. So getting all those embeddings, the numerical ones, and then we store them in our PG vector store. And then finally, using that model, we take our documents and we start to kind of build this ingester configuration, and finally just ingest the documents. So when I run the server, I am basically just taking the documents that are in there, and then they should be converted into an embedding, right? So let's take a look how that works. No, I do not want to run this query here for sure, because it's going to delete everything I have. You can see that I have the embedding store. I can see the data, and here you'll see that there's a lot of information here, right? So you see all the embeddings generated, and for normal humans, they are not readable, but for large language model, they make a lot of sense, right? So sorry about that. What I'll do is that I'm going to go on an SQL command, and I'm going to show you how it is looking from a textual perspective as well. So I'm going to search for embedding underscore ID and text from embedding underscore store. Right? I think that's what it should be. And I run this query. And by the way, I'm using Adminer, and I'm using Docker Compose locally, so it does that. And here you can see that, okay, it has actually created text, embedding text that from those documents. I'm not showing you the numerical representations, but these are the textual representations of how it has sort of chunked this, right? So if I go back to my code, what I did was that, hey, I want this to be 50 characters in size, max, of all the word split that I need. And I need a little bit of overlap. And overlap is interesting, and I'm just going to get into that, is how these embeddings sort of overlap. So they have sort of a connection that you can do a similarity search in a much, much more easier way. But here you see a full sentence, right? So if I go to my chatbot here and say, hey, um, you know, uh, who is AI Alex, right? And then it's going to tell me AI Alex is 30-year-old individual who is trying to replace the architect and codes in Java using Vim, right? So if I go back to my source code here and search in my document and say, okay, where is AI Alex? AI Alex trying to replace himself with an AI that codes in Java, right? So it does sort of bring some of that data back and say, okay, so what happened when AI Alex and Spring Boot Sally went for dinner, right? If I ask that question, it says, hey, I do not know who this is, try again. And why is this saying that? Because in my specific prompt, I have said, do not do anything else. Do not try to make stories out of it. Just tell me, do you know this person or not? So it doesn't understand who that person is contextually, right? So that's how I'm able to get away with that. But let's assume let's assume that we want to be able to do a bit more, and we have this document splitter, document by word splitter. What if I actually wanted to do this in a lot lesser, right, characters, as an example? And what is going to be the effect of me not splitting my documents correctly? Let's take a look at that. But before I do that, I obviously want to do is, like, I want to delete the embedding so it doesn't conflict. So let's do that. Embedding underscore store. Um, oops. Enter. That's a typical mistake we all make. Okay. So you can see I'm not so well versed with SQL anymore. Hibernate has spoiled me. Anyways, but so what I'll do is that now I say, hey, my max segment is 5. I don't want any overlaps, which means that it should not split my documents more than 5 characters, right? Which is pretty small, to be honest. So I'm going to start this up, and I'm going to look at we're going to start the server up, and then we're going to go back to the embedding. So as it starts, it takes a little while for me here because it's going to go back, connect to the database. I see things are happening. Yes, looks good. So if I go back here and say select embedding underscore id comma text from embedding underscore store, enter. And here you see that this has now changed, right? Now you see text is totally broken out. And if I go to my app again and say, hey, who is AI Alex? And it says AI Alex is an artificial entity named Alex. So it's totally forgotten about the person. Now it's hallucinating, right? It doesn't actually understand. So, and that's why it's sort of connecting things together, trying to make sense of it from whatever it has. But it's so far from away from truth, right? So so basically, it's not able to understand the similarity search that we did, and the reason is because of this specific text breakdown that we did in this scenario. So we could go back here and say, okay, I want to do something different. I want to do document by line splitter, right? And maybe that's a good one. And we just say, okay, we want about 50 characters or 100 characters here, right? So that will bring some context. But then what if I was also able to do an overlap, which means that it overlaps between the two of them, right? So, okay, something I did wrong here. It's going to start up again, but I have made a mistake here that I have not deleted this. So let's do that quickly. Delete from, and any questions in the meanwhile, please just throw them. And Buzzler, you can just tell me if there's any questions. I can take them then. Okay, let's do this. Start again. Okay, it's going to come up, and then I can show you how the embeddings are looking in here. I probably it's last time, but anyways, select text from embedding underscore store. And here you see that the text is way bigger, right? And now if I wanted to change my prompt and start to ask between relationships of the users, I would also be able to do that. So let me do that. Let me just go here, and I'm going to take this prompt that I already had, and I'm just going to paste it. And we're going to see that now, because the data chunks are bigger, we will see that it has a different meaning to it. It is able to do something different because of, one, the prompt, and two is the amount of data that we have chunked based on ourselves. So that kind of helps when we do something like that. So again, delete from embedding underscore store. And I think I'm slow on my time here, but let's see if I can make it. So Okay, perfect. So we have it. So if we say now we go come here, I'm just gonna enter. And okay, so who is a AI analytics? So now it's going to give me a little longer, right? Response. It's going to humor me a bit. Talks about AI Alex, ambitious soul who thought he could outsmart himself, etc., etc. Or ask the same question like, what happened when Spring Boot Sally and Thread Local Theodore went out for dinner, right? So it's gonna come up with something interesting again, like the story I said, right? But it's able to do that because now it has the context and the splitting in a much larger way as well. So hopefully that makes sense. And what I've done so far is obviously there are different text splitters. You can split based on documents, on chapters, on sentences, on paragraphs, and these are the different techniques that you would use. And the reason to show you this is that you would use them in different ways or different use cases. So for example, for paragraph and sentences, you are looking at something which is aiming or chunking the size and in a much broader context, and easier to work with when it maybe is code, or larger form of text that you need answers from, right? So that's like in our case, the first one was smaller. The second was the response was a larger chunk of text because we needed that from our prompt. So we made the text chunking bigger. From a character perspective, again, it is more specific that you can have more control. How you want, how many characters and words do you want on a specific chunk, and it gives you more control whether it's your in-house data, products, etc., that you might want to look at. The second last one, or the last here, is the line splitter. And line splitter is also interesting because then it gives you, let's say if you were writing poetry and specific text chunks in that format, then it will help you to do that as well. So let's move on to the last demo. I know I have 8 minutes. I'm extremely bullish about this, so we'll see. But I'm going to jump into the model context protocol. And for the model context protocol, Basler showed us the tools demo. He did not show us a very interesting demo, which is also part of our repo, is where we have an entire bookstore. And the bookstore has a book service, and the book service is using tools as well. And that's what we've basically used with. But the recent advent of model context protocol kind of brings us into another frame where we say, okay, why do we need model context protocol? It is going to standardize our content. It gives us this representation which can be used by other languages and other systems as well. But the way it works is that a user will ask a question to the large language model. And this is what was in the tools demo that pretty much Basler showed you as well. And once you ask that question to the large language model, it's going to request the tool for execution. So the control will come back to the client in that sense. But in the MCP server case, it's going to go to the MCP server, which will then execute tool, whatever tool that is, and then forward that request back to the large language model, and the large language model will send the request back to the user. So let's see how that works. I'm going to quickly show you that demo. I need to bring in my MCP backend, which is again built with JakartaEE. So as this starts up, I'm just going to quickly show you. I have step 09 here with the REST backend, a REST backend which has similar to the book service. We have a book resource, and the book resource has multiple methods here. That is categories, stuff like that, ISBN code, books, all of these that it exposes. And it is using the database, so it's storing all this information in the backend. So I would be basically, what I want to do is that I'm saying that this is my book service, let's say, which I wrote. So you might have an API, a REST API that you wrote, right? So that's my REST API backend that I'm using. But then to use the MCP server, as it's quite new, there are multiple implementations that are in works. The implementation that I chose for today is using the Quarkus implementation, right? And in the Quarkus implementation, Quarkus has its own MCP server extension, so I can actually write tools to do that. What I do in this MCP server is that I have a book client, which is my REST client. So I'm going to call my book service, and it's going to get all that data from my book service, right? And then what I do is I have something called tools, and here you'll see similar tool annotations as Boswell showed you. Okay, get all books from the bookstore, find book by ISBN, etc., etc., and it has all of that information, right? So what I'll do here is I'm going to start up my MCP server. For that, what I would do is that I would say mvn clean compile package, and this is going to go in, take my entire app. And here you see that there are no specific, in my code, there is no specific langchain for J, code here. It's a langchain for J binary here. It is basically just a tool annotation that is coming from the MCP server. So there's no binding at this point with that on the front of this, right? So on the back end, of course, there is. And then what I'll do is that I'm going to use a tool called Goose. And what Goose is a client CLI, which can load these MCP extensions. And so it's going to add this my Quarkus server that I built, which actually connects to the REST API. So if I go back into my resources here, you will see that I'm using the localhost 8080 LLM Jakarta to actually speak to the backend REST service that is spun up as my MCP backend using Jakarta on Wildfly, right? And then I'm going to use this Goose to actually, where I've configured my OpenAPI key, OpenAI key, and I'm going to add my Quarkus built Java jar file as a fat jar into this extension as well, right? So I go in here, it starts up, I say, do I have any, or do you have any books, right? And it's just gonna, let me just pick this up a bit. So it says, okay, I'm gonna get all the books for you. At this point, what it does is that the large language model calls my tool, which is within the server that extension that I added, makes that call. The tool makes that call, sends the response back to the large language model, and the large language model comes back with this return, right? So it's kind of giving me a much more flexible way of doing it, which means that I can add more and more tools to it, not just for one API, but for multiple APIs as well, right? So I would like to buy Java concurrency book. Is that possible? And again, this is natural language processing. So yes, it's going to go in and say, hey, looking at it, yes, the book concurrency is in stock, oops, and is available for purchase. Okay, I would like to buy 500 copies. Is that possible? And now again, it's going to go back and say, it says, unfortunately, there are only 30 copies of Java concurrency in practice, right? So it's basically picking up from my REST API, and I'm going to do something dangerous, which we'll see why we shouldn't do it, right? So I'll say, okay, what if I want to sell 500 copies to you? Would you buy them? So again, it can depend. Okay, I don't have the capability to purchase books or conduct transactions. However, if you're interested in selling books to the bookstore, you might consider reaching. Okay, interesting. So it hallucinates a bit. So what if I want to restock these books to you? Let's see if it picks up the update endpoint. Okay. So no, it actually changes. But fun stuff, that's how it works. Large language models will use the tools where we actually ask specific things. But again, you can do this in more natural language. And obviously, you don't want to expose your entire REST API to this. What you want to do is be able to expose enough functionality that is going to be used as well. So this was a very, very quick demo on how you could use model context protocol, which kind of gives you the flexibility over tools. So the question would be, when do I use tools and when do I use model context protocol? So they both sort of use tools, right? But I could create my own tool and have that within my own code. I don't want to go through the hoops of creating my own MCP server implementation. I don't want to use another framework or extension. I just want them within the tools. So that's very helpful for me, and that gives me a lot of flexibility. And that's how it will it becomes easier for me as a Java developer to do it. But then again, I might think, okay, I am a developer that is selling software or giving services to other software systems, and they might actually want to use these in their other programming languages and extensions. So could I actually do that? And yes, like for example, if it's energy data that is used by the public or train system data, etc., and you want to be able to expose some of that information, so MCP is a great way of doing that. So here I will end my presentation. We covered a lot of these different things here. Obviously, we would love to do it more, but we all have respect to time for you and for the organizers here as well. And finally, here's the last slide. You could follow us. There's a link to the source code here, and we also have the speaker deck. So we will also share that with you in the chat just now, so you can do that. So at this point, I'm just gonna pause my screen, and we are here, both me and Basler, in case you have any specific questions that you might want to ask us.
Thank
And
you
if
so,
not,
so
then
much,
very
Shaf,
much thank
for
you
the
for listening. And it was great talking. I attached the speaker deck here on chat. Um,
Thank you so much, Shaf, for the excellent presentation and Baslur. There is no questions in the Ask a Questions tab, but throughout the presentation, there was some questions, and I did see Baslur answer them
I don't
as
know,
they go.
Serena. I actually cannot hear you. I don't know about others, but
Can you hear me now? No?
I can hear you now. Yeah.
Perfect. Thank you. Yes. So there is no questions in the Ask a Questions tab, but I did see that Baslor was answering questions in the chat. So perhaps you could take some time, the both of you, and go there, make sure that everybody has the answers that they do need. For those that are asking about the recordings, yes, they will be posted on our YouTube channel. You'll receive an email communication with the direct link to the actual video. It is also always available here on Crowdcast. So if you want a quicker instant replay, you're able to replay it as well. So thank you very much, both of you. Amazing presentation, lots of engagement throughout the chat. We had a great attendance. Thank you so much, everyone. And you have yourselves a wonderful rest of your day. Take care.